Hi everyone. Tonight we're going to learn about theoretical and experimental probability. Okay, you've probably heard words such as theory, and I know you've heard experiment before, so hopefully some of this seems familiar. Okay, first we have some vocab. Okay, we talk about developing a probability model. Okay, there's two types, really, or two categories. The first is a uniform probability model. And if you think about uniform, okay, if somebody's wearing a uniform to school, that means all the students are wearing the same clothing. Okay, so when we think about a uniform probability model, it's a model in which all outcomes have an equal probability. They're all equally likely. Okay, so, think of a uniform. Everyone's wearing the same thing. Nobody has, better shoes than someone. No one has a better shirt than someone. Everyone's wearing the same thing. It's all equal. Okay? So this example says Ben randomly selects a counter from the group of counters below. He then records the color of the selected counter. Okay, to define the sample space, we just want to list what our possible outcomes are. Okay, so our sample space would be yellow, red, blue, green, and black. And remember, we want to put it in those squiggly brackets. Okay, then it says, what is the probability of selecting a counter with a particular color? Okay, so what are the chances that you choose green? Okay, we would say 1 out of 5, okay, or 1/5. And that should be true of all of them because there's one of each color and there's 5 total colors. Okay, and that's what we see down here in this chart. Okay, if we were asked to find the probability of choosing yellow, we would have 1 out of 5, 1/5. Probability of red, 1/5. Probability of blue, 1/5. Probability of green, 1/5. And probability of black, 1/5. Okay, and then what we can do is we can put our probability data into a bar diagram. Okay, and you'll notice that this looks a little different than our histogram, and again, we'll get into this extensively in the coming weeks, but a bar diagram is like a histogram, but the bars don't touch. Okay, so we have categories along the bottom, that's important. Okay, we have colors in this case, and our probability on the side. And you'll notice the probability of each one is 1/5, so all of the bars are the same height. And that's what helps us understand that this is a uniform probability model because the chance of choosing a yellow, red, blue, green, or black is all the same. Pause and rewatch if needed, and then flip to the next page. Okay, on this page, we're going to look at a non-uniform probability model. Okay, this is a model in which all outcomes do not have an equal probability. Okay, so in this example, it says that an art teacher has a bunch of colored pencils, 3 yellow, 6 orange, 2 green, and 4 brown. She randomly chooses a color to give to a student. Define the sample space. Okay, so again, listing our possible outcomes. Okay, what could she possibly pick when she chooses that color? Okay, she could choose a yellow, and we want to note that there are 3 of those. She could choose orange, and there are 6 of those. She could choose green. There are 2 of those. Or she could choose brown, and there are 4 of those. Okay. What is the probability of choosing a brown pencil? Okay, well, there's 4 brown out of how many total outcomes do we have? Okay, well, 6 plus 4 is 10, plus 3 plus 2, this is 15 possible outcomes. Okay, so the chance of choosing brown is 4 out of 15, or 4/15. Okay, we could calculate that for any of these. Okay, yellow would be 3 out of 15, orange would be 6 out of 15, green would be 2 out of 15. And that's exactly what we have in this chart. Okay, the probability of choosing each of the different colors. And you'll notice when we put this into a bar graph, the bars are all different heights because they all have different probabilities. And that helps us to understand that this is not uniform. Okay, and tomorrow you'll have an opportunity to practice building your own bar diagrams. Pause and rewatch if necessary, and then flip the page. Okay, so now we're really going to dive into tonight's topic. Okay, theoretical probability versus experimental probability. Okay, theoretical probability is the ratio of favorable outcomes to the total number of outcomes. And that's what we have right here. Okay, you have favorable over the total. Okay, I like to think of theoretical probability as what should happen. Okay, if you flip a coin 100 times, you should have the coin land on heads 50 times, and you should have the coin land on tails 50 times, because they each have a probability of 1/2. Okay, you have that 50-50 chance. Is that necessarily what's going to happen if you flip a coin 100 times? Okay, you could get lucky, but chances are you're not going to get exactly 50 heads and exactly 50 tails. And that's where experimental probability comes into play. Experimental probability is a probability based on data that's collected in an experiment. Okay, so if you flip a coin 100 times and it lands on heads 40 and tails 60, that's what actually happened. And it's close to what we expected, but it's not exactly what we were expecting based on the theoretical probability. Okay, so here's an example of using those two terms. It says, suppose there is a spinner with 3 equal sections colored red, green, and blue. Find the theoretical probability of spinning red. Okay, so in theory, okay, if these are all equal sections, it should land on red 1 out of 3 times, because 1 out of 3 sections is red. Okay, so that's what we would expect. Okay, so then the next step says if the spinner is spun 60 times, how many times would you expect it to land on red? Okay, well, if our theoretical probability says it should land on red 1 out of 3 times, we want to know how many times it'll land on red out of a total of 60. Okay, we can cross multiply. 3 times x is 3x. 1 times 60 is 60. Divide by 3, x equals 20. Okay, so we could say, in theory, okay, if everything goes according to plan, we would expect the spinner to land on red 20 times. Okay, and for that matter, okay, we would expect it to land on blue 20 and green 20. Because these sections are all equal, we would expect them all to have an equal number of spins. Okay, now, is that what's going to happen if you actually spin this 60 times? Probably not. And that's where we have our experimental probability. So down here it says the graph below shows the result of this experiment in which the spinner has 3 equal sections and is spun 60 times. Find the experimental probability of spinning red. Okay, so we guessed that it would land on red 20 times. If we look at the chart, it tells us that it landed on red 24 times out of 60. Okay, and that's the experimental probability. Okay, and we could say that it's close to our prediction, it's close to our theory, but it wasn't exact. Feel free to pause and rewind and then flip to the last page. On this page, okay, I want you to do questions 2 and 3 for me to check in class tomorrow, but I want to get you started on number 2. Okay, this number 2 says the spinner at the right is spun 12 times. It lands on blue 1 time. Okay, this is diving right into the experiment. Okay, but then it backs up and it wants you to find the theoretical probability. Okay, so ignore this for now. Okay, if you spin this spinner, how many times do you expect it to land on blue? Okay, or what are the chances that it would land on blue? Then go back to this to help you finish part B. Okay? Good luck, and we will check those tomorrow.